Lightning. You know, it's one of the most powerful and, well, familiar forces on Earth. But what if I told you that our basic idea of how it all gets started is probably wrong? Today, we're going to dive into a pretty radical new theory that says the spark for lightning doesn't come from inside the storm, but from deep, deep space.
So, let's just get right to it and ask the big question. How does lightning really begin? I mean, we see the flash, we hear the thunder, but that very first moment of creation, well, that's been a huge scientific mystery for decades. And trust me, the answer is not what you'd expect.
Okay, so most of us learned in school that lightning is basically just a giant spark, right? Kind of like the static shock you get from a doorknob, just way bigger. But here's the catch, the thing that has had scientists scratching their heads for years. When we actually measure the electric fields inside thunderclouds, they are almost always way too weak to create a spark out of thin air. And that's the core of the mystery, what they call the lightning initiation problem.
So let's really dig into this. Let's break down exactly why this is such a huge problem. Because to really get the solution, you first have to appreciate the scale of the challenge we're talking about.
To make a spark in dry air, say, down here at sea level, you need a staggering amount of power. We're talking an electric field of about 3 million volts per meter. That's what's known as the breakdown field. It's the force you need to literally rip electrons off of air molecules and get a current going. And yet, when we send balloons and airplanes right into the heart of a storm, the electric fields we measure are often 10 times weaker than that breakdown number. So that leads to this massive question. If the generator isn't powerful enough, how does the engine even start? How on earth does a billion-volt lightning bolt get going in an environment that shouldn't even allow for a tiny spark?
Well, the answer, according to this incredible new mechanism, is that the process doesn't start inside the cloud at all. Nope, it starts with a little help from outer space.
Believe it or not, it all starts with a single, super high-energy particle, a cosmic ray, maybe one that was shot out from a distant supernova millions of years ago, slamming into our upper atmosphere. This one single collision creates a massive cascade of millions of secondary particles that just rain down, seeding a huge part of the thundercloud below.
This cascade has a name. It's called an extensive air shower, or EAS for short. And you should think of it less like a single bullet and more like a cosmic shotgun blast. It delivers millions of these little starter electrons, the seeds of lightning, all across a huge area of the cloud, all at pretty much the exact same time. This is the secret ingredient that we've been missing.
But that cosmic trigger, it doesn't create the big lightning bolt itself, not directly. Instead, it ignites something way stranger inside the cloud, a whole swarm of tiny microflashes.
You see, a thundercloud isn't just one uniform blob. All the turbulence creates these countless tiny, invisible pockets. You can think of them as little tinderboxes, where the electric field is actually strong enough for a spark, just for a moment. That extensive air shower we talked about, it acts like a universal match, lighting up thousands of these little tinderboxes all at once, creating these tiny flashes we call streamers.
So get this, the very first moment of lightning isn't one big event. It's actually a storm within a storm, a whole swarm of thousands of little micro-discharges all firing at once. This synchronized flash is what scientists call the initiating event, or IE. It's the very first, very faint whisper that a new lightning bolt is about to be born.
But these tiny flashes, they don't last long. To get from that to a full-blown lightning strike, they have to be used for something else. They have to be used to build something much, much bigger. This is the construction phase.
So each one of those little streamer flashes leaves behind a tiny, hot, conductive channel of plasma. Scientists call these unusual plasma formations, or UPFs. The easiest way to think of them is like short, glowing pieces of wire. Or, even better, like Lego bricks. They are the raw material you need to build the final lightning channel.
And here's how the whole construction project works. First, that cosmic trigger makes thousands of these UPF bricks. Then, over a few microseconds, which is actually a pretty long time in the lightning world, these UPFs start connecting to each other, building out longer and more complicated 3D networks. It's this quiet, almost invisible process of building a conductive highway right through the sky.
And you know, like any good construction project, this all leads to a really dramatic climax. This is the moment when all that quiet building suddenly results in the first major, powerful event.
So after all that patient construction, you now have these two large, separate sections of this plasma highway just kind of growing. And the first powerful event of the lightning flash happens when these two massive networks finally find each other and connect.
And that connection is incredibly energetic. The research calls it a breakthrough, as the two networks finally link up, creating this powerful surge of energy. This is what produces the first really bright pulse of the whole lightning flash, something they call the initial breakdown pulse, or IBP. You can think of it as a practice swing before the main event.
And here it is. This is the aha moment, the proof. Because when scientists look at their radio and electric field data from a lightning flash, they see this exact pattern. It starts with a very weak little blip, the IE. Then there's a relatively quiet period of building, and then bam, you get the first strong pulse, the IBP. The real-world data perfectly matches every stage of this wild new theory.
So what this really means is that lightning isn't a single spark at all. It's this complex, multi-stage construction project all triggered from space. I mean, this fundamentally changes how we see our own atmosphere. It suggests it's all part of this much larger cosmic electrical circuit. A star explodes on the other side of the galaxy, and right here on Earth, its ancient echo can help trigger a thunderstorm. It's just incredible.
It's an amazing story of cosmic particles and atmospheric physics all working together in a way we never imagined. And it kind of leaves you with one final thought, doesn't it? If something as familiar as a lightning strike is this complex and surprising, what other profound secrets are hiding right there in front of our eyes?